Hey guys, welcome to this video. In this video, we'll be pretty much talking about all the same concepts that ma'am has already taught us in the class. So, if you are very well aware of it, you can just choose to skip this video. There's nothing more than what has been discussed in the classroom already. So, let's talk about statistics and story. Let me tell you a cutie story. So, there is an argument between two boys. It is a very important argument for them. Both of them are arguing who is the better ODI batsman. Is it Kallis or Sangakkara? Now they want someone else to give them a solid answer. So they both of them, let's say that they take this argument to a statistician. And the statistician obviously has to deal with all the stats and they have to arrive at a solution methodically. So the question with the statistician is the statistician has to verify if Kallis is better than Sangakkara. Now please pay attention to the question here. We are asking if Kallis is better than Sangakkara. It is not that is Sangakkara better than Kallis, or it is not that are Kallis and Sangakkara are on the same level. It is Kallis better than Sangakkara. This is very important because this is the line that gives you an idea about how you form an hypothesis for any problem. So before finding a solution, the statistician would go and take the population statistics, and we have it with us already. So these are the runs which Kallis and Sangakkara have scored for so many matches that we have had. Let's say that these are the statistics of Sangakkara for a total population size of about 343 matches. And these are the population statistics for Kallis for a total population of 184 matches. And we also have this data, which is the standard deviation of the population, which is denoted by sigma. So we have standard deviation for both the samples. So Kallis and Sangakkara are the samples here. So we have two samples and we know their standard deviation. So if the standard deviation is known, then we have to do a Z test. And since we are comparing means of two samples, which is Kallis and Sangakkara's innings, we are going to do a two sample Z test. So the next thing after arriving at what type of test you are going to perform, you have to formulate the hypothesis. Now coming back to the question that we had, is Kallis better than Sangakkara? So the statistician has to approve this statement, right? So this statement would become your alternative hypothesis. So whatever you are trying to prove or disprove, that would become the alternate hypothesis, and the other one, which they call it as the status quo, or which is the normally accepted condition, that would be the null hypothesis. So these are the hypotheses that we have. H1 is alternate hypothesis and H0 is null hypothesis. Since we are trying to prove that or trying to arrive if Kallis is better than Sangakkara, so the alternate hypothesis is average of Kallis is greater than Sangakkara. Since we are taking the average as the measurement of knowing who is a better player, it could be anything. It could be the number of 50s or 100s they have scored out. It could be the strike rate, but the statistician for some weird reasons have chosen using the mean as a measure. So the statistician is trying to prove if Kallis is better than Sangakkara. So the alternate hypothesis is mu k greater than mu s. And pay attention to the null hypothesis here. Now the obvious question is, if the alternate hypothesis is mu k greater than mu s, the next immediate question would be, shouldn't be the null hypothesis be mu k less than or equal to mu s? Now this is quite obvious, right? Because the thing is, both mu k less than or equal to mu s as the null hypothesis, or mu k equal to mu s as the null hypothesis, pretty much makes the similar sense. But it's about how you state it. So here we are saying that there is no much significant difference between those two people. Our only target is to prove or disprove if Kallis is better than Sangakkara. So if it is proved, we would say Kallis is better than Sangakkara. If it is not proved, we would say Kallis is not better than Sangakkara. We won't say that Sangakkara is better than Kallis. So that is the difference here. So these are the null and alternate hypothesis. Now the next step would be to arrive at the critical value for the test. Now since it is a Z test, we call the critical value as ZC. This critical value depends on two parameters, which is your alpha and the type of test, if it is a single tail or a two tail. Now alpha value has to relate to this term called as confidence level. For example, let's say that the statistician wants a confidence level of 95%. It means that whenever the experiment is being repeated 100 times, 95 times this conclusion or the inference that the statistician have made should hold true. For example, let's say that the statistician gives a final statement that Kallis is not better than Sangakkara, and if both of them play 100 matches, for 95 matches his statement should be valid. So that has to do with alpha level. So the alpha is calculated by 1 minus your percentage of the confidence that you are taking. So if your confidence percentage is 95%, then your alpha value would be 1 minus 0.95, which is 0.05. So yeah, and then we have a single tail or a two tail test. Now when you come back to your hypothesis, through the hypothesis and especially through the alternate hypothesis, you will come to know if it is a single tail or a two tail. Now our alternate hypothesis is greater than, right? Mu k greater than mu s. So our test is a single tail test, and since our alternate hypothesis has a greater than symbol, our test is a right tailed single tail test. So single tail is of two types. One is right tailed and the other is left tail. Yeah, one is right, the other is left. Anyways, and then we have our two tail test. So these are the differences that we have. The first picture shows a right tail single tail test, and the second picture shows a left tail single tail test, and the third one is a two tail test. The shaded region is your alpha value. For example, the area under a whole normal distribution curve is 1, right? So if your alpha is 0.05, then the area of the shaded region is 0.05. If your z value, that is your z value, calculated value, falls within the shaded region, you would reject the null hypothesis. If your z value falls in the non-shaded region, you would reject the alternate hypothesis. The statement made is quite clear. You can only reject an hypothesis. It shouldn't be like you accept an hypothesis. Ideally, you should either reject your null hypothesis or you reject your alternate hypothesis. And why does your alpha depends on single tail test or a two tail test? So here's the deal. A normal distribution curve is symmetrical, right? So let's say that if your test is a single tail test and a right tail test, the whole of the right tail or the whole of the alpha value would fall on the right side of the graph. So the whole area would be 0.05 if your alpha is 95%. Let's say that your confidence is still 95%, but you are going through a two tail test. So looking at the third picture here, on one side of the distribution curve, you will be having an area of 0.025, and on the other side of the graph, you will be having an area of 0.025 because the curve is symmetrical and the alpha value gets divided on both sides. And how to find the point? I mean, this point is called as a critical point, the point beyond which your area falls. Just give me a second. I'm trying to find my pen, but I couldn't. Where is it? Yeah, here is it. So this point is called as a critical point. So if your calculated z value falls beyond this point in a right tail test, you will reject the null hypothesis. If it falls on the left side, which is the unshaded region, then you would reject your alternate hypothesis. So that is the significance of the critical point. So the first step in hypothesis testing would be calculating your critical point. So as I said, critical value depends on two things, which is your alpha and your type of test. And here, since our alternate hypothesis mu k greater than mu s, we are having a single tail test, which is right tailed, and your alpha value, let's assume it to be 95%. Sorry, your confidence level is 95%, so your alpha value will be 0.05. So how do you use these two to find the critical value? For this, you have to refer to your statistical table, which for some weird reasons I haven't opened it. I'm very sorry about it. So here you have your statistical table. So we arrived at alpha as 0.05, right? And it is a single tail. So you have to find the point where your shaded region, the area of the shaded region is 0.05. Since it is a symmetrical curve, it doesn't matter if your z value is positive or negative. While writing it out, you will probably change signs according to what you write. So let's find where 0.05 lies here. It lies somewhere between these 2 points. Somewhere between minus 1.6, minus 1.6, what is this? Minus 1.64 and minus 1.65. So let's take it as approximately as minus 1.6. Yeah. So this would be your Z critical value. If your Z calculated value falls beyond this, you will reject your null hypothesis because we are doing a right tail test here. So for calculating the Z value of the statistics that you have to use this formula. So how do you arrive at it? Now when the statistician, whenever they deal with this kind of problem, they will take some samples, right? So let's assume that the samples that the statistician has taken are these samples. How did we arrive at this? We used a random number generator and we arrived at sample size, which is not in scope for this term, so you can just ignore it. So these are the sample values that we got. For Sangakkara, we have taken a sample size of 30, and for Kallis, we have taken a samples of about 25. So the statistician is using these samples to arrive at a conclusion. So what are the values that we have to find now is XA bar, which is your sample mean X of Kallis, and XB bar, which is your sample mean of Sangakkara, and then this mu A minus mu B. Now when you come back to your null hypothesis, we are giving the null hypothesis as both are equal. There is not much change. There is no much difference. So your mu A minus mu B in this case would be 0. And your sigma A and sigma B are the population's standard deviation of Kallis and Sangakkara respectively, which is calculated already or which you know. And then your NA and NB would be the sample sizes of Kallis and Sangakkara's innings. So Kallis's sample size would be 25 and Sangakkara's sample size would be 30. So we have calculated the mean also through a average function in Excel. So you can just substitute. So here we have the calculator. So you can just substitute all these values in the formula and you arrive at your Z value as 0.03, which falls. So let's come here. So if we look at the graph again, we arrived at our Z value as 1.6, right? But now the Z calculated 1.6 is your critical value. But now when we calculated Z, our calculated Z value is 0.03, which lies somewhere here, which is in the unshaded region. Now since our calculated Z value lies in the unshaded region, you would reject your alternate hypothesis. And your alternate hypothesis is Kallis is better than Sangakkara, and we have found out no, that's not the case. Kallis is not better than Sangakkara, and that's how you arrive at your inference. So we found the test statistic Z value as 0.03. So Z calculated is less than Z critical, and alternate hypothesis is rejected. Why? Because it is a right tail test. So how do you arrive at your, or how do you infer this, or how do you say it in a statement is Kallis is not a better ODI batsman than Sangakkara. You won't say Sangakkara is a better ODI batsman. You would ideally say Kallis is not a better ODI batsman because you reject an hypothesis. You never accept it. You either reject your null hypothesis or you reject an alternate hypothesis. So yeah, this is pretty much how you do a 2-sample Z test and a right tail test. For left tail test, it is very similar. The only difference would be in a left tail test, your Z calculated value should be greater than your Z critical value. And in your 2-tail test, it should lie between the 2 critical values for you to reject the alternate hypothesis. So thank you guys. It is a long video, quite slow, but yeah, thank you. And one more thing, should I say thank you or should I say thank you? Anyways, thanks. Bye.